Welcome back everyone to this section on Advanced SQL topics. Basically, this section consists of a variety of topics that didn't really fit in well with the flow from the previous sections because they don't actually need to be learned in any particular order. So what we're going to be talking about first is a variety of functions. We'll first deal with timestamps and the extract function, just a variety of functions and tools available dealing with things like dates and times. And then we'll talk about various math functions, and then we'll talk about some string functions. After that, we'll learn about two separate topics. One will be the subquery, basically a query within a query, and then we'll also talk about a self join. Let's go ahead and get started. I'll see you at the next lecture. Welcome back everyone to this lecture series on timestamps and extract functionality. In part 1, we're going to focus on displaying current time information. So as I just mentioned, in this lecture, we're going to be going over a few commands and functions that report back time and date information. Something to keep in mind is that these functions will be more useful when we're creating our own tables and databases rather than when we're just querying a database. We're going to be learning about creating our own tables and databases later on in the course, but it makes sense to learn about a few commands and data types right now. So we've already seen in our tables that PostgreSQL can hold date and time information. For example, we saw that timestamp data type column for things like when a customer actually rented a DVD. Now keep in mind, there's actually different subsets of data types that refer to things like storing time information or date information. And the four main ones are the time data type, which contains only time, such as hours, minutes, and seconds. Then there's the date data type, which contains only a date, the month, day, and year. And then there's timestamp, which essentially combines both of those and contains both date information and time information. And then there's timestamp TZ, or timestamp time zone, which contains date, time, and time zone information. Something to keep in mind, and we'll talk about this later on when we're learning about creating our own tables and databases, is you should have or perform careful considerations when designing a table and database and choosing a time data type. Keep in mind, depending on the situation, you may or may not need the full level of dates, times, and time zones. For example, if you're designing a table that will calculate how many hours people worked, you may actually just need time information, the time they clocked in and then the time they clocked out, especially if each row represents a work shift. There's no point in keeping track of time zone because you don't expect this person to be changing time zones in one shift of work. Now, something to critically remember is if you are keeping track of historical time information or date information or timestamp information, and you're trying to perform some sort of calculation, like maybe how many days were worked or something of that nature, you can always remove historical information. For example, if you're keeping track of timestamp TZ, and later on you discover you don't actually need time zone information, you can always remove that time zone information. But what you cannot do is go back and add it in because you were never recording it in the first place. So that's really the careful consideration to make, is that if you're recording time or date information, and you decide later on that you wanted to go back and also record time zone information because maybe your company expanded globally, you can't actually just make that information pop out of nowhere. So you should always have that careful consideration and try to think long term when choosing a particular time data type. Now, with that being said, I want to just quickly explore a couple of functions and operations related to these specific data types, and those are time zone, now, time of day, current time, and current date. And as I mentioned, these are more useful when we're creating tables or having a table automatically populate entries based off when something is actually created, like what time is this row actually being created. So we're going to quickly go over these, and don't expect them to be super useful for queries, but later on we'll encounter some of these functions. They're pretty self-explanatory, so I'm just going to head straight to pgadmin and work through a few examples. Okay, here I am in PostgreSQL, and I've connected to my DVD rental database. Now let's first show you how to actually understand and grab what is your current time zone that you're working in. And the way we do that is with the show command. And we haven't actually seen this before. Keep in mind, I'm not going to do select, I'm going to do show. And the main command people can use with show is show all. And if you check out the documentation for PostgreSQL on show, it shows the values of a bunch of runtime parameters. And there's a list of parameters here, and you can scroll down and view more information on them. But if you just say show all and then run this query, I'll go ahead and run that, you'll notice there's a name of a parameter, the setting it's currently on, and then a description text basically telling you and explaining what that name and setting refer to. So for example, my current application is pgadmin4, and if I keep expanding on this, it'll tell me what actual connection I'm on. And if you scroll down, there's actually about 300 different parameters you can see here. And so one of them you can check out quickly is time zone. Go ahead and run that, and you can see here that on the computer I'm working on, that my current time zone is US Eastern. Okay, so that's how you can figure out what time zone you're working with. Now, if you actually want to get the current timestamp, and recall timestamp includes both date and time information, here we come back and we'll say select, and then we're going to call the now function. So it's now open and close parentheses, which basically just says, give me the timestamp information for right now. And once you run that, you'll be able to see that you get a timestamp with a time zone set of information. So you can see the date and then the time, as well as information concerning what actual time zone you're in based off standard GMT, which stands for Greenwich Mean Time, and you can just do a quick Google search on that, which is basically just an international way of marking what time zone you're in. So you can use select now to get your current timestamp. One thing to notice is that this gives it to you in kind of timestamp format, which is sometimes a little hard to read. If you want it as a string, you can say select time of day, open and close parentheses, run that, and this returns back basically the same information, but as a string, labeling it Thursday, March 19th, and then time, and then the year, as well as the time zone. So a little easier to read, and possibly a little easier to store and grab components from, because it's just a text string with that information. It's actually no longer a specific timestamp style. And then finally, the last two commands are basically subsets of this. Instead of grabbing the current timestamp, you can just grab just the current time, which would be select current time, run that. That gives you just the time with time zone, or you could change it to current date, run that, and that basically just gives you the current date. Okay, so now we know how to grab the time zone information, the full timestamp with now functionality, and then how to grab the time of day, which is the string representation of the timestamp that it currently is, and then how to grab current dates and current time subcomponents of that. This will be a lot more important when we're creating different rows in our tables and then trying to log stuff of when it was actually created. We won't typically be asking for what the current date is with SQL just like this. Instead, just use your clock. Okay, so coming up next, we're going to focus on timestamp functionality that's related to querying tables and databases. So I will see you there in the next lecture. Welcome back, everyone, to part 2 of our lecture series on timestamps and extract, where we focus on extracting time and date information as well as formatting it. So we're going to be exploring how to extract information from time-based data types using the extract function, as well as using the age function, and then we'll also learn about formatting time information using the toChar or toCharacter functionality. So let's start with extract, which allows you to extract or obtain a subcomponent of a date value. And you're allowed to extract the year, month, day, week, and quarter. And you can always check out the SQL documentation for more information on this. But basically, what this does is if you have a full timestamp and you only want the year component of it, you can extract just the year. So the usage would look something like this. You would say extract, and then in parentheses, you pass into the extract function the subcomponent you want to extract, and we put it in all caps just so it's clear to whoever's reading this that we are extracting the year, and then we'll say from, and then whatever date column we're trying to extract this from. The age function calculates and returns the current age given a timestamp. So you simply just pass in some timestamp column into the age function, and that will return something that looks like this: 13 years, 1 month, 5 days, and if you also have time information, it'll include hour, minutes, and seconds, etc. So what that's doing is it's just taking the current date that you are querying and then calculating how old the timestamp in the actual database is. So if let's say the year was 2020 and you had a timestamp from the year 2000, then it would return back 20 years. So it's just calculating how old is that particular timestamp given when you're actually querying it. So just its age. And then finally, this toChar or toCharacter functionality is just a general function to convert data types to text. And it's actually not explicitly used just for timestamps. You can use this on lots of different use cases, but it's very useful for timestamp formatting in particular. And we're going to go and explore the documentation a little further when we actually work through some examples. But basically, the usage of this is you say to_char, and then inside this toCharacter function, you're going to type in as a first parameter the date column name, and then comma, and then as a string parameter the text formatting you want. And notice there's going to be specialized codes as far as how you actually want to format the month, days, years, etc. And we're going to be exploring the documentation to see a full table of the different template formatting for that. So all of these functions are really best understood through example. So let's jump straight to pgadmin and work with these functions, as well as explore the documentation for translating a timestamp to a character string. All right, here I am at my query editor. What I'm going to do is I'm going to select everything from the payment table just so we can explore it once again. And notice that all the way at the end, we had this payment date, which is a timestamp without a time zone. So let's start going through the couple of functions we just learned about. The first one being the extract function. So the way this works is, and we'll separate this out into two lines. We say select, and then we extract, parentheses, and here we get to decide what we actually want to extract. So if we wanted to extract just a year from that payment date, we'll say year from, and then we type in that timestamp column name. And notice what we get back. We're getting back a certain part of that date, and then we get back 2007. And it's really useful to use this along with the alias in order to say something like as, and you can call this like my year, run this, and then you get my year. So you could also just say year, run that, and you get back year. Notice that year is highlighted here because it is technically a specialized keyword of SQL because it can be used as a subcomponent to extract from a date. So here again, typically you're going to select, extract, you're going to select something to extract, such as the month from payment date, and then call it, let's say pay month, or whatever you want to actually call this column. And there you see pay month, and here's the second month. So these all happened in February, etc. And you can do it for all the ones we mentioned, such as quarter as well. Start typing these on multiple lines, run this, and so this happens in the first quarter of the year. Because it was February, the first quarter is January, February, and March. So we can see here, this payment happened in the first quarter. Very useful for things like business. Okay, so we have the extract functionality in place. Let's say we wanted to figure out how old a particular timestamp date was in regards to our current date. To do that, we simply say select, and if we say payment date, notice here we have that timestamp again. The age function, if we take a look at it, is going to allow us to calculate how old this particular timestamp is. So for example, if something or someone was born on this particular date timestamp, how old will it be right now? And obviously you'll get different results because you won't run this at the exact same time I will. So if I run this, here I get to see the age, and it's 13 years, 1 month, 5 days, and then hours, minutes, seconds, and then subseconds. All right, so that is the age functionality. And then finally, the one I want to show you in a little more detail is toCharacter. So the way this works is we say to_character, then we decide on the timestamp column we're going to be working with. We say comma, and then as a string code, you get to decide on the formatting. And as I mentioned, toCharacter is just a generalized function for converting from one data type into a text data type. And if we take a look at the documentation for this, which is under data type formatting functions, or if you just Google search to_char, it'll get you to this page. I'm going to zoom in just a little more so we can read this. And basically, what this allows us to do is, as a function, grab some data type and then convert it to a text data type. So typically, you can see the first one here is you grab some timestamp and you convert it to a string. And there's going to be specialized template formatting codes. So if you scroll down here, notice there's different patterns you can use. And essentially, these are the specialized patterns you can combine in any way you want in order to organize the text however you see fit. So notice if you just say one single Y, that's the last digit of the year. Two capital Ys is the last two digits, 3, and then 4, etc. You can also do things like have capitalized month, which is the full uppercase month name, or if you just say all lowercase MON, it's the abbreviated lowercase, so 3 characters in English. Depending if you're on a localized version of your language, it may vary, etc. But notice there's lots of different ways you can ask for the month. So let's go ahead and play around with this. So we see here that we have a timestamp. Let's go ahead and format it to be month dash YYYY. So we run this, and because we have month in full caps, it's going to report back February. This dash is just the dash that I decided to use there. So if I remove that dash and just have a bunch of spaces, run this again, then the string code is just going to have some spaces between month and these 4 capital Ys. So keep in mind, now I can add in whatever string, text, or characters I want in order to format my date as I so choose. So let's imagine that you're running something from the United States and somebody asks you for a report on this payment date organized, let's say by month, then day, then year. So what you can do here is, let's take a look at the documentation here. We're going to go ahead and use, let's say, all lowercase MON. So we'll say all lowercase MON /, and then if you take a look at the table, you can get the dates just as 2 numbers with lowercase dd, and then we'll go ahead and just have Y's there. So we run this and we get back February 15th, 2007. And then on second thought, you think it looks kind of weird to have the 3 letters. So you come back in the documentation, you see here MM is the month number, which probably makes more sense. So we'll come back here and replace this with MM, run that, and now I see 02/15/2007. And these / dashes are just / that I got to decide on. If I wanted to, I could have made these just normal dashes, run this, and note how my string is going to keep getting edited. Now let's imagine we're running this query from a European standpoint, and we actually want to have the formatting be correct for European standards, in which case I would have the day first, and then come in with the month, another dash, and then have the year, and notice how that starts to get flipped around. Okay, so a lot of this is just looking up here in this large table exactly the template pattern for your date time formatting. Again, it's a large table, but you should be able to find whatever you're looking for, and then you can add in your own strings or own characters in order to format it however you see fit. So that is the 2-character function. And as I mentioned, later on we'll see that it's actually able to format not just timestamps, but a variety of different things. So you can format an integer to be a string. So convert an integer to a string, and then maybe only show certain precision levels. Okay, so that's it for this lecture. I will see you at the next one. Welcome back, everyone, to a few challenge tasks concerning timestamps and extract that we just learned about. So we're just going to give you 2 tasks for you to answer, and as always, we'll go ahead and give you the expected result, the hints, and the solution. So your first task is to answer the following. During which months did payments occur? And also, format your answer to return back the full month name. Okay, so let's go ahead and see the expected result. So the expected results are these 4 months. We should see payments happening in March, May, February, and April. Coming up next are some hints. So the hints is that you do not actually need to use extract for this query. So keep that in mind. If you're having trouble figuring it out with the extract function, see if you can use something else we learned about in the previous lectures in order to get your answer. And here comes an example solution. So our solution is to say select, and then what we're going to do here is we'll do the following. We'll go ahead and grab the payment date and then grab the month from that payment date as a string by saying 2-character. And if you just run that, then you'll have a bunch of rows listing the full month name, and then we can just select the distinct month names, and from the payment table, you have your answer. So again, our example solution is to simply convert the payment date to a month-long string, and then we can select the distinct months represented. Time for your next task. So your next task is how many payments occurred on a Monday. Something to note here is I didn't show you exactly how to grab something like a Monday or a Tuesday or a day of the week, but I do want you to be able to either use the documentation online or just a quick Google search in order to figure this out. So we're trying to push you in order to be able to use the different resources available for you online in order to answer real world questions. So again, the task is how many payments occurred on a Monday? And here is the expected result. So the expected result is 2,948 payments occurred on a Monday. And then here come some hints. So the hint is for this one, I would recommend using extract. And if you're stuck on what the keyword is for day of week, I would tell you to search the documentation or Google around for DOW as a keyword. And the last thing to consider is that PostgreSQL considers Sunday as the start of the week, and it's indexed at 0. So 0 corresponds to Sunday, and then 1 corresponds to Monday. Okay, here comes our solution. So our solution is to simply select count everything, or asterisk, and then from the payment table, where, and we're going to say extract the day of week from the payment date, where it is equal to 1. Because if you extract DOW from payment date, that will give you back the numerical day of the week, so 0 Sunday, 1 Monday, etc. And we're only considering the days of the week that are Monday, so we say where this is equal to 1, and then we count how many rows are available after that. Okay, so that's it for your quick challenge tasks. If you have any questions, feel free to post the Q&A forums. I'll see you at the next lecture. Welcome back, everyone, to this quick lecture on mathematical functions. We're going to quickly explore some mathematical operations that we can perform with SQL. And this is actually all just best shown through some examples, and also by showing you where you can find all the examples of mathematical functions in the documentation. So to do this, I'm going to jump straight to pgadmin in my browser. Okay, here I am inside of pgadmin with my query editor ready to go. I first want to quickly show you the documentation for mathematical functions. And if you come to the PG-SQL documentation and then just go to functions-math or just search for mathematical functions and operators in Google along with PG-SQL, it should bring you to this page. You can also check out the URL here at the top, postgresql.org/docs/current/functions-math.html. And there's lots of different operations and functions. What we're really going to focus on throughout this course are mathematical operators, because that's more common to use for business SQL queries. And the way this works is, as you may expect, it's just things like addition, subtraction, and multiplication done between columns. So you can add one column to another or subtract one column from another, etc. So it also gives you examples and then the expected results. So pretty much any mathematical operator you can think of is available to you in PostgreSQL. So this operator you type in, its description, and examples. Now, in case you happen to be doing more complex mathematical work, there's also mathematical functions. We're already familiar with one of these, which was round. Remember that rounded off a number to a certain number of decimal points. But there's things like absolute value, cube root, exponential, even logarithms are available too, and lots of different options here. So for our particular databases, we don't need to be taking anything raised to some sort of power or be converting degrees to radians, but I want to let you know that this stuff is available to you in case you need it. And there's even trigonometric functions. So there's random functions here, and then there's trigonometric functions as well as hyperbolic functions. So lots and lots of different options. So in case you find yourself needing to do some sort of complex mathematics within your SQL query, go ahead and check out this documentation page and see if the function is already available for you. Now I'm going to show you just a couple examples of how you may actually use some of those mathematical operators and functions from within pgadmin in your queries. First, let's go ahead and select everything from the film table. Go ahead and run that. And I'm going to zoom out just a little bit so we can see the results here in a little more detail. Looks like we have a film ID, as we know, title, etc. And what I'm going to focus on are things comparing the rental rate versus the replacement cost. Let's imagine I wanted to know the percentage that a rental rate versus a replacement cost happens to be. So what percentage of the replacement cost is a rental rate? So the way I can do that is the following. I simply need to calculate rental rate divided by the replacement cost. So if I run that, notice we get back this result here. And if you get it back like this, kind of squeezed down with a lot of numbers, just remember you can always expand this back out because it's keeping a lot of decimal places. So I also wanted this in terms of percent, which the first thing I'm going to do is I'll go ahead and round this off to just be 2 decimals. So we'll say round this result to be 2 points past the decimal. So if I round that, now I get to see 0.33, 0.25, etc. And then what I can do is if I wanted to get it in terms of percent, just times by 100. So then I can see 33%, 25%, etc. And if I wanted more detail there, I could say keep 4 from the original, run that, and now I get to see 33.29%, 24.96%, etc. And you can always say an alias here as something like percent cost or whatever you happen to name this column. And you can see here it's percent cost. Okay, so this is kind of typically what you would do. Let's imagine for some reason you wanted to just put small deposits down of 10% of the replacement cost. You could easily calculate that. You would just say something like 0.1 times the replacement cost, and then you can name it something like as deposit from film, run that, and we can see here we have 10% of the replacement cost for some sort of deposit program. All right, so really it's all pretty self-explanatory here. You can always jump to the documentation and explore any mathematical operators that you see fit to use. Okay, thanks, and I'll see you at the next lecture. Welcome back, everyone. In this lecture, we're going to be discussing string functions and operations. Luckily, PostgreSQL provides us with a variety of string functions and operators that allow us to do things like edit, combine, and alter text data columns. Let's jump to the documentation as well as pgadmin to see what's available to us and also work through some typical examples. Alright, here I am inside my browser. I have pgadmin open, but before we explore it, I want to just show you the documentation page for string functions and operators. So if you go to this page in the documentation, it's postgresql.org/doc/current/functions-string, or you just look up string functions and operators plus PostgreSQL. You'll notice that very similar to the mathematical functions page, it gives you a list of functions, the return data type, descriptions, examples, and then results. So you can take a look at the different types of functions you can do, things like string concatenation, so you can concatenate 2 strings together in order to get some sort of result. You can also do things like check the length of strings, lowercase strings, etc. So lots of different things, searching for substrings within a certain pattern, as well as pattern and regular expression matching. You can check out section 9.7 in the documentation for more details on that, in case regular expressions and pattern matching is something you're already quite familiar with. Recall that we also have like and I-like as operators that can be used with things like wildcards. There's other string functions as well, things like converting from a string to some sort of encoding depending on what language you're using, etc. So lots and lots of different options here. We definitely don't have time, nor do we need to really go through all of these, since a lot of them you won't really experience yourself in a typical query, but we will go over some really common use cases, especially with this string concatenation. Often you want to assemble some sort of string or text data based off other columns. So let's jump to pgadmin 4 here and explore just a few typical examples. We're going to be dealing with the customer table, so I want to quickly show you what's in the customer table in case you have forgotten. So let's run this. We can see we have customer ID, store ID, and what we're going to be working with here is the first name and last name. So notice that these customers already have an email. Later on, we're going to be showing you how to possibly construct an example email through a SQL query in case you had to do that. But first, let's show you how you can perform a very simple function call that operates on text data. For example, let's say we wanted to grab the length of the first name of somebody. To do that, we would simply look up in the documentation how you would actually grab the length. And if you start searching here for things like length, eventually you would find by scrolling down and kind of exploring this that there's actually a length function. So you just follow the example here. Here all the examples are shown with actual strings, but you can just pass in a text data column instead. So we'll say select, and you can put this in all caps if you want just for formatting purposes. Select length from first name or from customer here. We run this and now we have the length of that first name. So maybe you wanted to use that as some sort of identifier. Okay, now let's show you how to perform concatenation. In fact, if you go to the documentation, it's one of the very first things they talk about, string concatenation. And what they do is they use these two pipe operators in a row, usually on your keyboard that's right above the backslash. So let's go ahead and concatenate first name along with last name. So if we say first name space two pipe operators and then last name from customer, we run that. A couple things to note here is there is no space currently between the first name and the last name in the results. Also, this column doesn't have a name. Let's go ahead and fix these. Let's start off with fixing the fact that there is no space there. So we just told PostgreSQL to take the first name and immediately concatenate it with the last name. If we want, we can add in another concatenation of just a space string. So note what I'm doing here. I'm saying first name concatenated with this empty space. So notice there is a space here in between these two single quotes, and then concatenate that again with the last name. So now when I run this, I get the spacing between the first name and the last name. And you could replace this with whatever you want. So if you wanted to put 2 dashes there, notice now there's 2 dashes there. So we'll keep it as just a space. And then the other thing we wanted to fix here was the fact that we just had this kind of weird question mark, column, question mark. So we can use the alias to work with this. We'll say select first name, last name as, and let's just go ahead and type this as full name. We run this, and now we see we've been able to change that data output to be full name. So a very typical query here for using string concatenation. You can always put in other functions as well onto these columns and concatenate at the same time. For instance, we could uppercase these by using upper and pass those columns into this. So we can say upper here as well. And now when we run this, notice that the full name is now in full uppercase. You can always expand this column width to see the full results. And now let's show you one last kind of more complex example. To reiterate, I'm going to select everything from the customer table. Let's imagine that for some reason we didn't already have an email for these customers, or maybe even for some employees, and we wanted to create an email for them. Well, often, if you work at a company, you may realize this, but there's an email method where you just take the first letter of the first name and then add in their last name, and then add in something like at whatever your company name.com is. Let's see if we can follow that simple process using SQL. So what I'm going to do here is I'm going to do this in a couple of steps. First, we know we need to concatenate the first name or first letter of the first name, then the last name, and then let's just use @gmail.com for our example purposes. So I'm going to do the following. We'll say first name concatenated with last name concatenated with, and then as a string, we'll just say @gmail.com. So we run this, and so far we have a couple of things here. No, I said we want just to use the first letter of the first name, and also something that maybe isn't exactly a problem, but we do want to fix this in our examples here for practice, is the fact that we have both the first name and last name still capitalized. So let's go ahead and fix the issue first of, instead of grabbing the whole first name, I just want to grab the first letter. Now, if you're exploring the documentation or you do a quick Google search on this, you would eventually figure out that there is a function called left, which returns the first n characters in the string. And to give you an example here, if you call left on A, B, C, D, E, and then 2 as a second parameter, it returns back A, B, which are the first 2 letters, which means we can use left on the first name column along with a 1 to grab that first letter. So let's go ahead and run that. We'll say left on first name, comma 1, in order just to grab that first letter. So now we have J, M, P, etc., Ellie, Smith, Johnson. So we're able to grab just that first letter. And now let's go ahead and lowercase everything. We'll call lower on these results. So we'll do lower on last name as well. Run this, and we have the expected email addresses. And if we want, we can always say something as our custom email that we created. Run that, and this is a very typical example of using string functions and string operators in order to basically create a new column that is useful for a certain situation, such as creating customer email addresses. Okay, so definitely a big part of this is exploring the documentation and feeling comfortable with it. Thanks, and I'll see you at the next lecture. Welcome everyone to this lecture on the subquery. In this lecture, we're going to be discussing how to perform a subquery as well as how to use the exists function in conjunction of a subquery. A subquery allows you to construct more complex queries, essentially performing a query on the results of another query or using the results of another query. The syntax is relatively straightforward and involves the use of two select statements. Let's imagine some hypothetical table that consists of the student names and their resulting test scores. So it's a very simple table of just two columns, which means a standard query on this table, if you wanted to grab everything, would look like the following. We say select the student column, comma, grade column from test scores. And this would return back two columns, a student's name, such as Jose, and then their grade, let's say 95%. Let's imagine you wanted to grab the average grade across the entire class. Then you would just say select average grade from test scores. So we already know how to grab all the information from the table, as well as the average score or average grade from all the students. Now let's imagine you wanted to answer this question. How can we get a list of students who scored better than the average grade? Given what we already know so far, it looks like we need to actually do this in two steps. First, we would have to get the average grade and then write that down somewhere and then compare that to the rest of the table against it to filter out the students. This is where we can actually use a subquery. So, this is where a subquery can help us get the result in a quote-unquote single query request, essentially just needing to type out everything one time. So the way we would do this is the following. We would say select student grade from test scores where grade is greater than, and here in parentheses we have our subquery where we're going to have select average grade from test scores. So notice what we're doing here. We're first going to run the code that's inside the parentheses, the subquery, and that's going to return back the average grade across the table. Then we're going to be able to use that result in order to select students who have grades greater than the average. So recall that inside the parentheses, since this is going to be run first, this is going to yield some sort of result, such as 70. And then, once that subquery is done and returns its results, SQL is then going to run this other query outside of the subquery. So you'll end up getting a list of students and their grades where they happen to be above 70 or whatever the average happens to be. So this allows us to simply type this out instead of having to do two separate queries, writing the results out of one and then using it in another. And this is now going to be flexible to any changes within the table. The subquery is performed first since it's inside the parentheses. Keep in mind we can also use the in operator in conjunction with a subquery to check against multiple results returned. For example, let's imagine we wanted a subquery that operated using a separate table. So we wanted to grab the students and grades from the test scores table where the student happened to be present inside another table. So we could do this with a join, possibly, but the other way we could do it is with a subquery. So we could, in our subquery, say select the student name from the honor roll table, and then that would yield back some results of the student names. For example, let's say Zach, Chris, and Carissa are the students in the honor roll, and then after that subquery is then executing, we can say select the student and their grade from test scores where student is in this list of students. So note here, this seems to follow along very similar to a join, but sometimes, especially for complex queries, it's easier to think of them as a subquery. Now the exists operator is used to test for the existence of rows in a subquery. Typically, a subquery is passed in the exists function to check whether or not any rows are returned with a subquery. So the typical syntax would look like this. We say select some column name from some table name where exists, and then the actual subquery. So select column name from table name where we have some sort of condition. And then that's going to return true or false depending on whether or not there were any rows returned. So subqueries and exists are really best learned through example. So let's go ahead and jump to pgadmin and work through some examples of using a subquery as well as the exists function within pgadmin. Okay, here I am inside pgadmin. Let's go ahead and work through an example similar to what we saw in the slides of a subquery. So to do this, I'm going to first select everything from the film table so we can remind ourselves what the format is. It looks like the film table has film ID, title, description, etc. And it also has a rental rate. Let's go ahead and calculate or return back the films that have a rental rate that is higher than the average rental rate for all the films, similar to the test score example. So the way we do that is we start off by, depending on how you want to work this from the inside out or the outside in, let's go ahead and start with the subquery. So the subquery should be first calculating that average rental rate. So the average rental rate of all the films, if we expand on this, we can go ahead and see it's $2.98. So this is going to be our subquery. Instead of having to use the scratch pad and write down this number, let's go ahead and have this be more dynamic. Wrap this in parentheses, so now it's a subquery. And then what we're going to do is say select. Let's go ahead and select the title column and the rental rate column from the film table where, and here we're going to say rental rate is greater than, and it's going to be greater than the results of this subquery, which is $2.98, which means when I run this, I should see back all the rental rates here, $4.99, $2.99, etc. These are all greater than $2.98. Okay, so notice here that this subquery in parentheses will get executed first in order to calculate that average, and then it becomes part of this larger query. The other thing that's important to notice is this particular subquery returns back just a single value, the average rental rate, which means it's okay to use a comparison operator against it, such as is equal to, is greater than, is less than. If your subquery, however, returns back multiple values, then you need to use the in operator on it. So let's work through a more complex example where we're going to actually use a join along with a subquery. So the subquery is going to actually have a join in it. So first, let's explore a couple of tables that we haven't seen in a while, so I just want to make sure we remember them. I'm going to select everything from the rental table. So if we run this, let me expand this back out again. We have a rental ID, a rental date, inventory ID, customer ID, and then we have a return date, which is what we're going to be focusing on, and then a staff ID and a lab or last update. We also have inventory. So let's check our inventory table. Run that. This has an inventory ID, film ID, store ID, and then a last update there. So let's imagine we have a situation where I want to actually grab the film titles that have been returned between a certain set of dates. So if we go back to select everything from rental, we have this rental date. Let's go ahead and grab all the films that have been returned between, let's say, May 29th of 2005 and May 30th of 2005. So that would be select, in this case, everything from rental. And then what we're going to do here is say where this return date, if we come back here, we have this return date is between 2005 and let's say May 29th and 2005 May 30th. So we run this, and now everything here has been returned basically on May 29th. Okay. So notice here that in the actual rental table, I do not have the film ID. So if I want the film ID, I'm going to need to join this rental table with inventory, which actually connects the inventory ID, because notice here I have an inventory ID, so I can use that in conjunction with the inventory table to then grab the film ID. So I have a specialized primary key for each rental, and then I have the inventory ID, So I'm going to use that. So let's say instead of selecting everything from rental, we're going to say select inventory dot film ID from rental, and let's perform a join on this. So we'll say inner join on inventory dot inventory ID equal to rental dot inventory. Make sure we spell this right. Inventory underscore ID. Now let me zoom out just a tad so we can see this whole thing. So what I'm doing here is I'm going to grab the film ID from the inventory table because it's not available to me on the rental table. And then I can use the inventory ID column that happens to be in both inventory and rental table in order to join these together. And then I'm filtering based off the return date. And if you want, you can specify the return date being part of the rental table, but it's only found in the rental table. So you can either do where rental.return date or just return date because it's exclusive to just one of the tables. So you don't need to specify what actual table we're looking at. So let's go ahead and run this. And now I get back this list of film IDs. So this is the list of all the film IDs that happen to be returned between these two dates. Now let's imagine I wanted the title of these. Well, what I could do is I could use this as my subquery, and now I have this list of results, which means I can use the in operator. Again, note this subquery is returning back multiple results, so I can use the in operator. And now I can just say select film ID, comma title from film, where the film ID is in, and then we have this list of film IDs. So I run this, and now I get back the film ID as well as the title. Keep in mind, PostgreSQL is going to operate this as efficiently as possible. So the order is not going to be maintained. If you do want to do some sort of ordering, you would do that at the very end after this last parentheses, because technically this subquery happens first. It gives you back that list. Then you organize everything here. And then at the very bottom on the last line, make sure this is outside the parentheses of the subquery. You can say order by something like title, and it will order by title. Or alternatively, you can order by the film ID. Okay, so that is a subquery using the in operator because the subquery returns back multiple results. And finally, let's walk through an example of using the exists operator. Let's imagine we wanted to find customers who have at least one payment whose amount is greater than 11. And we actually want to grab the first name and last name of those customers. The way we can do this using the exists operator is the following. We'll say select the first name and last name from the customer table, and we'll go ahead and say customer as C, where, and this is where we're going to use the exists operator. So recall that the exists operator basically just checks to see if rows exist in the actual returned subquery. So that means we're going to do this. We're going to say exists, and in the subquery, we'll say select. We'll just go ahead and select everything from, and we'll say payment as P, where, let's put this on multiple lines. It's a bit easier to read. We'll say where P dot customer ID is equal to C, which is the original customer table, dot customer ID, and amount is greater than 11. So note what we're doing here. We're going to say select the first name and last name from the customer table, where, and then the exists operator is checking to see if any rows are returned based off this subquery, where we're saying select everything from the payment table where the payment customer ID matches the customer ID and the amount they paid, which comes from the payment table. If you wanted, you could say p.amount, but amount is exclusive to the payment table, so we don't need to clarify further, is greater than 11. So if we run this, we get back the names of, in this case, if I expand on this, these 8 people. So this is our first and last names of people who happen to have at least one payment whose amount is greater than $11. So in this example, what's happening is for each customer in the customer table, the subquery checks the payment table to find if that customer made at least one payment. So if that particular customer made at least one payment using this matching criteria, and that the amount is greater than 11. If you wanted to do the opposite of this, essentially check for customers that have not made any payment greater than $11, you could add a not operator in front of exists there. Run this, and then you would get back basically any customer that did not happen to be one of those 8 customers. Okay, that's it, and I'll see you at the next lecture. Welcome back, everyone, to this lecture on self-join. A self-join is a query in which a table is joined to itself. Self-joins are useful for comparing values in a column of rows within the same table. So the reason we talk about this as Advance SQL commands instead of in the join section is because this sort of use case is more dependent on your table structure and the actual question you're trying to solve. So it's not as common as just a normal inner join, for example. So let's discuss self-join in a little more detail. The self-join can really be viewed as just a join of 2 copies of the same table. Keep in mind the table is not actually copied internally, but SQL performs the command as though it were. And the other thing to keep in mind is there's no special keyword for a self-join. It looks just the same as a simple standard join, and it carries the same syntax with the same table happening to be in both parts. However, when you are using a self-join, because you're using the same table, it is necessary to use an alias for the table. Otherwise, the table names would be ambiguous within the self-join. So let's see a syntax example of this in order to see what I'm talking about when I mean the same tables being joined, as well as those table aliases. So here we can see the syntax for a self-join. I'm saying select table A.column, comma, table B.column from table as table A, join table as table B on table A dot some column matching to table B dot some other column. So what's actually happening here? Well, the main thing to focus on are these table names. Notice in green here, we're saying from table as table A, join table as table B, which is me assigning 2 different aliases to the same table. This is what allows me to perform the self-join. The main thing to keep in mind is that even though you see representations of table A, table B, and just table here, all of these are actually referring to the same table. We're just using the aliases in order to organize this. Okay, so I think this is best explained through an example. So I want to show you a more realistic situation of when you would want to actually use this. Let's imagine that we have a company and we have some employees in this company. And employees have to send reports to other employees. So I have this table of employees with their primary key, employee ID, which is just a unique identifier per employee, then the name of that particular employee, and then the ID of the person they need to send a report to. So each employee sends reports to another employee. For example, here I can see that Andrew, employee number 1, sends a report to employee ID number 3, which happens to be Charlie. So Andrew's sending reports to Charlie, Bob's also sending reports to Charlie, Charlie is sending reports to employee ID number 4, so that's David, so Charlie reports to David, and then David sends reports to employee number 1, which is Andrew. Now let's imagine I wanted to show the results of the employee name and their report's recipient name. So I want to go from this employees table to something that looks like this on the right, where I have the name and then the person they're reporting to instead of just the report ID, which is the employee ID of the person reporting to. Technically, all this information is in this one singular table. So I can use a self-join to essentially make a copy, join it together in order to match the employer name or employee name with the report ID along with the employee ID. So let's break this down. Here again we have the generalized syntax, and let's start swapping out the components given what we want to accomplish here, going from this employees to just the name of the person they report to. So what I'm going to do is first focus on the tables, because that's really what we're doing here. First things first is we have the main table. So we already know the name of that table is just employees. So if I take a look at my employees table, that's just the name of the table I'm working with. So I'm going to replace that with employees. And now it's time to select the first alias, which is table A. So what I want for my first column is the employee name. So I want to think of this as referring to the employee name based off the employee ID. So I'm just going to refer to that as EMP for employee. Then the second thing I want to do is focus on the person they report to. So for table B alias, I'll go ahead and label that, thinking of it as based off the report ID. So I'll label that as report. Then I need to decide what column am I going to join this on. Well, recall that the employee underscore ID column corresponds with the report ID column. The report ID column was just representing the employee ID number. And then the column we actually want to select happens to be the name for both this theoretical employees table and this theoretical report table. And this is the final syntax. So this will take our singular employees table and return back the results of one column of employees and then the second column of those same employees, but the person they happen to be receiving reports from. And in order to make sure you don't get two columns with name, we can always say that second column should be as rep. So essentially an alias for that second column. That way we don't see name. Instead we see name rep as shown here. So we want results showing the employee name and the report's recipient name. And again, make sure you kind of pause and make sure you understand the syntax and how we were essentially just swapping out the tables and swapping out the aliases. Let's explore a quick example on our own DVD rental database. Okay, here we are in PG Admin. Let's imagine that I wanted to answer the question, find all the pairs of films that have the same length. If we take a look at the film table, so select everything from the film table, we have the title of the film, and then if I scroll over, I also have this length column. So what I'm going to be doing is just focusing on that title column and this length column. And I essentially want to figure out what other films happen to match up together as pairs that have the same length. So if we take a look at Chamber Italian, for example, which is the first one that I got, notice here it's 117 minutes. So if I say select title length from film, where length is equal to 117 minutes, and run this, notice that there's, besides Chamber Italian, 4 other movies, Affair Prejudice, Graffiti Love, Magic Mallrats, and Resurrection Silverado, that share the same length. But my final result, the way I want it to look, is to have 2 sets of titles and then their matching length. So essentially I want to have these paired off, Chamber Italian with Affair Prejudice, then Chamber Italian again with Graffiti Love, Chamber Italian with Magic Mallrats, and then Chamber Italian again finally with Resurrection Silverado. So how can we actually do this? Well, to do this, I would essentially need 2 copies of the same table. So this is perfect for a self-join. So what we're going to do here is forget about this where for a second, and I'm just going to run this. So we have select title length from film. First, let's decide how we actually want to format this. I'm going to pretend that I have 2 tables, film 1 and film 2, or F1, F2. So I'll say F1 title, comma, F2 title, and then I have to decide to grab the length from one of the tables, so we'll do it from F1. That way, I can get something that looks like Chamber Italian, the Mallrat one, or whatever that film happened to be called, and then, or Resurrection Silverado, and then 117 minutes. So it's going to do this for all possible pairs of films that have the same length, at least with the ones that, for the first instance, it found it in the title column. So then we're going to say from film as F1, and then we're going to do an inner join on film as F2. And this is where we have to decide what we're actually going to be joining on. So I'm going to say join film as F2 on, and I'm going to say grab film ID from F1, and I actually don't want to set it equal to F2 film ID. Instead, I want to say not equals to. But in order for this to make sense of why we're doing a not equals here, I'm first actually going to do it incorrectly with an equal sign. So if my F1 film ID is equal to my F2 film ID, and then I say and F1 length is equal to F2 length, notice what I'm asking here for. I'm basically just going to match up, for example, chamber Italian with chamber Italian again in the next table, or its copy. So if I were to run this, I'm just basically matching each movie with itself. So what I actually want to do is make sure that, for example, chamber Italian's film ID doesn't actually match with any of the other film IDs in the table, but does happen to match with the same lengths. So we're going to say not equals to here. So that's the kind of fundamental difference in order to answer this question. So now when I run this, notice what happens. I get back chamber Italians matched up with the other titles that happen to share the same length in runtime. So what I'm doing is I select film 1 title, film 2 title, film 1 length from film as F1, interjoin film as F2. So these are the aliases necessary in order to perform the self join, and then on. In this particular case, in order to answer the query, I had to say not equals to the film ID. But I did want to make sure that their lengths matched up. And that's an example of a self-join using that DVD rental database that we've been playing around with. Okay, thanks, and I'll see you at the next lecture.